Welcome to part 3. This is all about the diagnosis of pylori infections. So there are going to be 3 things to think about here. Endoscopy, and then blood tests, and then carbon-14 breath tests. So 3 parts to this short presentation. Okay, so endoscopy. Endoscopy is the use of a flexible device that can be passed down through the upper digestive tract and into the stomach, and that can be used to then obtain tissue that can be used for histology or for an assay called the Clow test. So let's just look at this image on the left. On the left, we've got a hematoxylin and eosin, H&E staining of normal gastric mucosa, and so we don't see any evidence in there of any bacteria. Everything looks healthy. And just to orient you, let's just point out the gastric pits here. So here is the epithelia of the stomach, and then bear in mind this is highly folded tissue, and so if we take a section, we could also be looking down onto a pit like this, and we could have the bottom of a pit, so there's very little aperture here. But these are all gastric pits, and this is where pylori would set up residence if there was an active infection. So the biopsy can be obtained by endoscopy, and then that can be silver stained, and we can see on the right hand side all of these little black spiral bacteria, the spiral gram-negative rods that we've looked at. We can see them colonizing the gastric gland, and so that would be positive as a pylori infection. And alternatively, the sample can be used for the Clow test, which was developed by Brian Marshall, who we met in the first part. And the Clow test is based on the pH change that is produced by the conversion of urea to bicarbonate and ammonia by the urease enzyme. And so we obtain the sample by endoscopy, and then a small amount of tissue is used in the Clow test, and if the test is positive, like it is here on the right, then the pH change that's caused by the urease producing bicarbonate and ammonia turns the little dot in the middle there red, and if it's negative, we get the yellow dot, which is on the left, and so that's basically a pH-based test. And so there are 2 things we can do with endoscopy. Just to summarize, we can look at histology, we can do some staining, and we can look at the actual presence or absence of the pathogen, or we can do these Clow tests. And let's move on quickly to blood tests and to 14-carbon breath tests. So the blood tests, let's start there with point 2. Now, your humoral immune response produces antibodies against bacterial antigens. And so the presence of those antigens is indicative of pylori infection. You can also detect antigens in stool samples as well, obviously because of the nature of where the infection is. But in the case of stool sample, the sample has to be appropriate. It can't be diarrhea, that kind of thing. The problem is that the test is indirect. It can be time-consuming. Obviously, the blood test requires a needle stick, which is problematic for people who have needle phobias. And you also get some false positives here with some of the relatives of pylori. So if someone has a Clostridium jejuni or a Borrelia burgdorferi infection, but Borrelia burgdorferi causes Lyme disease, if someone has either of those pathogens, jejuni or Borrelia, then you can get some immune cross-reactivity based on the nature of the assay, and so that's a little problematic. Also, the test is obviously not indicative of a new infection because the antibodies may persist for a long time after the organism has been eradicated. So you may have the antibodies against the bacterial antigens, but you may not have the actual infection. So that's obviously problematic. Okay, so those are blood tests very quickly. More interesting and kind of a neat little assay is the carbon-14 breath test. So the carbon-14 breath test is going to detect carbon-14 in urea. So how does that work? So a patient would fast for about 6 hours, and then they take a small pill that contains 14 carbon labeled urea. Now that may sound a little alarming to some people, but there's about the same amount of radioactivity in that little pill as there is in about 15 glasses of orange juice. So if you're a prolific orange juice drinker over the course of a week, week and a half, 2 weeks, you would take in the same amount of radioactivity. So there's no real risk here, to be honest. Plus, 14 carbon is a very weak radioactive emitter, so there's not going to be a whole lot of damage to tissues due to taking in that 14 carbon. So if pylori is present in the stomach, then the radioactive urea that is taken in the little pill, that gets metabolized by the urease enzyme to radioactive bicarbonate, and then the ammonia. Obviously, the ammonia doesn't contain any carbon, and so the radioactive carbon is in the bicarbonate. And so, if we just look at our little diagram here, here is the 14 carbon urea that is being taken in the pill. It goes down into the good old stomach. The ammonia, no carbon, so that's just going to be secreted. The 14 carbon bicarbonate is actually ultimately going to be converted to carbon dioxide in the lungs, and what you do is you exhale that 14 carbon dioxide in your breath, and it's used to inflate a 2-liter mylar balloon, and then that gas is transferred to a counting vial that can be used in a sensitive scintillation counter, and the amount of radioactive 14 carbon dioxide gives you an indication of whether an infection has occurred or not. So that's a pretty neat little assay, and so just to summarize, we've got the endoscopy, which can be used for histology or the Clow test. Then we've got the blood tests, which look for pylori antigens. And then we've got the 14 carbon breath tests. And the next thing that we will look at in a short video is some epidemiology of pylori infections.